Once the Hubble Telescope was considered the benchmark in space exploration, NASA believed in going even higher. Thus came the James Webb Space Telescope, the JWST, launched at the end of 2021. This space telescope is named after James E. Webb, NASA's administrator from 1961 to 1968. This telescope is a massive success in exploration in space because this telescope is going to help us find galaxies that we never knew even existed before. In a few years, the JWST will take the place of the Hubble Telescope as part of NASA's mission of taking astrophysics to the next level. This telescope is designed to improve the infrared resolution, the IR of pictures, received from space and be 100 times faster than the faintest objects that the Hubble Telescope detects. Although the JWST has been in development for years now, we could never have predicted that there would be such an object which would tell us about the hidden galaxies outside our own. If you think about it, such technology takes more than 2 decades to create. And speaking of 2 decades, that is the mission lifespan of this impeccable telescope. Background. Speaking of the background of this telescope, it comes for $10 billion. And it is the largest telescope that NASA has ever made. This telescope has a primary mirror that measures around 21.3 feet, whereas the sun shield measures 69.5 feet by 46.5 feet. The overall mass of the JWST is 6,500 kilograms. This telescope will also be orbiting the Sun in an entirely different Lagrange point, which will assist this telescope to stay in the same line as that of the Earth. It is predicted that this telescope will take precisely a month to travel 1,000,000 miles to the permanent position. This telescope results from the collaboration between NASA, the European Space Agency, the ESA, and the Canadian Space Agency. NASA also involved around 300 universities and organizations and companies across 29 states in the United States and 14 other countries to produce this technological marvel. This telescope will probe our entire physical universe, which we call the cosmos. This will help us to know what secrets this universe is holding within it. There will be such significant advantages that the JWST has over the Hubble telescope that the Hubble might look obsolete when the JWST operates at its full potential. Application. The first thing this telescope will be able to do is deploy an incredible sun shield that will help protect its surface from the sun's UV rays. Being more expensive than anything NASA has ever created, for a venture like this telescope comes with many safety measures and precautions. The orientation and alignment of this telescope are what will come into play. As for the entire functionality of this telescope, it is still in process. Once this completes, this telescope will bring us clear pictures of interstellar space. Even though this telescope is slated to replace the Hubble telescope, the first few months in which it will be deployed, the two will be working together. The James Webb Space Telescope will look at our universe in infrared, and it will cause light from distant objects to shift to longer wavelengths, at the red-colored end of the spectrum. This will bring in bigger and better details to the images that will be seen, as it will manage to give details about the most primitive stars and galaxies that the universe has inside of it. Another critical point to note is that the James Webb Telescope will orbit the Sun. It's oriented that this will remain in its gravitational space instead of drifting away to the sideways. Plus, since this telescope will orbit the Sun, this explains the sun shield, which we've discussed earlier. Objectives. The principal objectives of this telescope is to find a planet that is similar in terms of its conditions and inhabitants to the Earth, but that would require a massive stroke of luck because the probability of this happening is very low. Planets similar to the Earth are pretty rare in the neighborhood of the Earth, as we know about the planets outside our own solar system. They unfortunately do not exist until we do not locate them properly. These planets are faint compared to their parent star, and it is expected that this telescope will most likely study the gas giants such as Jupiter or Saturn. On the flip side, ice giants such as Uranus and Neptune present in our solar system will also be studied. With several planets closer in orbit than ours, there will be several times when we could expect conditions to be hot or cold. Apart from this, the telescope will dissect the findings of the Big Bang. The Big Bang is the concept of the coming together of our universe, courtesy of protons, neutrons, and electrons. There was no light before the universe cooled down, and these particles began to combine. This telescope will go in depth on how our universe was created and where it stands in terms of space after billions of years of existence. This telescope will focus on the organization of matter to see how different galaxies formed together in big and small sizes. Cosmic entities of different structures will be seen as they evolve from different structures. The formation and detection of galaxies can't be done so simply, which is why this telescope is going to assist us in the process. For this method, the Webb team continues to make progress as it aligns the telescope and other successful activities, including the collaboration of the NIR ISS filter wheel and pupil wheel tuning for the NIR cam. There are hundreds of processes like these lined up, and each of them is more important than the next one. This will ensure that the Webb can achieve its scientific goals. A postdoctorate researcher at NASA's Goddard Space Flight Center, L.Y. Aaron Young, explains all about this telescope and how it will work, which can then help us analyze our galaxy better. This summer, Webb will start searching for galaxies in the distant universe. These highly anticipated observations are the key to unlocking the secrets in galaxy evolution and our universe's history. Depending on the specific science goal of an observing program, the best-suited survey configuration can vary a lot. For instance, galaxy surveys going after the faintest and most distant galaxies require long exposure times. Example, NG Deep and Premier. Still, surveys for large-scale cosmological structures would require large survey areas. Example, Cosmos Web. Inputs for physically motivated simulations are essential to developing optimal observing strategies to achieve the specific scientific goals. To create a simulating universe, we first lay the foundation with dark matter concentrations, or halos, extracted from cosmological simulations. Dark matter accounts for 85% of the matter in the universe and has a dominant effect on the spatial distribution of galaxies across the universe. We then simulate the galaxies forming inside these dark matter halos based on astrophysical processes we learned from past observations. Because light travels at a finite speed, the light that originated in the early universe has traveled billions of years before finally reaching us today. This effectively allows us to look back in time and see the universe billions of years into the past. Our simulating universe serves as a basis to create mock observing fields that are statistically similar to the observed universe. The physically motivated models have been shown to match the galaxies observed by Hubble. Example, the Hubble Ultra Deep Field, and we use them to provide predictions for galaxies beyond Hubble's capabilities. We process the simulated universe further into realistic mock images by adding effects from scientific instruments and survey configurations. These data products are used to support the development of the Webb data reduction pipeline and will inform the interpretation of further observations when they become available. Webb will detect for the first time in human history galaxy populations forming shortly after the Big Bang, and theories paving the way for the search. In turn, Webb's observations will refine our understanding of galaxies and the history of our universe. With so many details being told by Young, this information is invaluable. With such a complex instrument, there's no doubt that it will require several complex practices and procedures to find out the secrets hidden in our galaxy. The JWST will be a game changer for us in the world of space with a masterstroke from NASA. This telescope will do wonders once it manages to align itself correctly. We can't wait to see what this telescope has in store for us as it begins to capture pictures of our galaxy and beyond. That's all we had time for today. Make sure to give this video a thumbs up. And of course, subscribe to the channel, not to miss any upcoming videos. We're going to see you again in a new video very soon.